Hi class, this is part 3 of section 1.6. We will continue our discussion on absolute value inequalities. Example 5, solve each inequality. For part A, we have the absolute value of x minus 3 is less than or equal to 1. So on our number line, the shaded region in orange represents everything that is within 1 unit of 0. So we can go from -1 to +1. We are between -1 and +1. And we have our inequality, -1 is less than or equal to something, which is less than or equal to 1. So in our blank spot, we need to write in the x minus 3, what we have inside the absolute value bar in our question. So -1 is less than or equal to x minus 3, which is less than or equal to +1. We'll then add 3 to all 3 parts of the inequality. So we have 2 is less than or equal to x, which is less than or equal to 4. This answer should either be written in interval notation so we have 2 to 4. We'll use brackets since we have that or equal to, or set builder notation. So all row numbers x such that 2 is less than or equal to x, which is less than or equal to 4. Okay, so notice that in our picture over here, the people are all together. Okay, they're at the same time, they're greater than -1 and less than +1. So since they're all together, we write it as a 3-part inequality. Your inequality is also all together. Okay, so here's a problem worked out. Add 3 to both sides to get that x is between 2 and 4. Interval notation and set builder notation. Okay, so here's another one. We have the absolute value of x plus 4 plus 3 is less than 5. So notice that this plus 3 is not within the absolute value bars. So we're going to subtract that over first. Then we'll have the absolute value of x plus 4 is less than 2. Okay, so again, if this was on a number line, we have to be within -2. We have to be in this region from -2 to 2. I'll put open circles here since we have a non-strict, since we have that strict inequality. The absolute value is strictly less than 2. Okay, so if we're drawing in our people, right, they all go here, they're all together. So we write our inequality as a 3-part inequality. So -2 is less than x plus 4, which is less than +2. Subtract 4 from all 3 parts, and we have -6 is less than x, which is less than -2. Interval notation, -6 to -2 with parentheses, or set builder notation, all row numbers x such that -6 is less than x is less than -2. When you're doing your homework in My Math Lab, the directions are usually specific on how they want the answer written, so it'll either be interval notation or set builder notation. On an exam, that it's up to you if it's something that you're writing down and turning it on paper. Okay, so here's another one, part C. This time we have the absolute value of 4x minus 9 is greater than 5. So we're talking about things being more than 5 units from 0. Okay, so anything that's more than 5 units from 0, you've either gone more than 5 units and you happen to be to the left, meaning you're less than -5, or you've gone more than 5 units and you went to the right, so you're greater than +5. Okay, so our dancing people are either to the left of -5, meaning they're less than -5, or they're greater than +5. So we have to write this as an or statement. The people are either on the left or they're on the right. Okay, they're not in both places at the same time. So if they're on the left, then they are less than -5. If they're on the right, then they're greater than +5. Okay, so here in the blanks, we're going to write what we have inside our absolute value bars. So 4x minus 9 is less than -5, or 4x minus 9 is greater than +5. Some students have a hard time with this because the inequality symbol that we have in the original is different than the inequality symbol I have here in this first inequality that I wrote. But once you look at the number line, it should make sense. These dancing people went more than 5 units to the left, which means they are less than -5. Okay, so it was a greater than inequality to begin with because they went more than 5 units, right? But since they went to the left, once they do that, they are less than -5. Okay, we're going to solve our two separate inequalities. So let's add 9 to both sides. We'll have 4x is less than 4, divide by 4. X is less than 1. Or I will add 9 on both sides to my second inequality. 4x is greater than 14. Divide both sides by 4. We'll have x is greater than 14 over 4, which reduces to 7/2, 7 over 2. Okay, so either we're to the left of 1, meaning we're in this interval from -infinity to 1, or we're greater than 7/2, which is 3.5, but I'll write this as our improper fraction, 3 over 2. Either one's fine, 7 over 2 or 3.5. Okay, x is greater than 7/2, so 7/2 to infinity. That would be interval notation, step builder notation, all real numbers x, such that x is less than 1 or x is greater than 7/2. Okay, so again, if you're writing something down and submitting it to me, the directions will ask you to use either interval notation or step builder notation, so it's up to you. Again, in my math lab, just follow the instructions that are there. Okay, notice that our answer is in two separate parts, right? We're either here on the left or we're here on the right. Just like in the picture, you are either in one section or in the other section. Okay, so I've added 9 to both sides. Here I did them both at the same time, so I added 9. Divide everything by 4, reduce your fraction. Interval notation, or write the answer in step builder notation. And then I also wanted to show you a graph. So later in the semester, we'll be graphing absolute value functions. So we're not doing it yet. I just wanted to show you what the graph of the absolute value of 4x minus 9 would look like. So it's our v function that's here in green. The question was asking us, when is that going to be greater than 5? Okay, so in orange we have the line y equals 5. Okay, so we see if we look down here at 1 and then at 3.5, right? So if we're to the left of 1, if we have any of these values over here, -2, -1, 0, and 1, and we plug that into our function, we're going to be way up here. We're going to be at some number that's bigger than 5. Same thing if we take a number starting at 3.5 and becoming bigger, going to the right from 3.5, plug it in, and we'll be way up here on this right portion of our absolute value function, okay, of that v function. Okay, so everything that's in between, so between 1 and 3.5 here, That's the portion of the graph that stays below 5. And we wanted everything that was greater than 5. Okay, again, if the graph was confusing, we're going to talk about absolute value functions later. I just wanted to show it in case anyone does like to look at a visual. Hopefully that helps. Okay. All right, one more like this. So this time we have the absolute value of 3 minus 2x is greater than or equal to 7. So we have our number line. I'll put 0 in the middle, 7 and negative 7. We want the absolute value to be more than 7. So I shade on the outsides, more than 7 units from 0. Okay, so our people are either to the left of negative 7 or to the right of positive 7. If they're to the left of negative 7, they must be less than negative 7. So 3 minus 2x is going to be less than or equal to negative 7, or they're on the right-hand side. So 3 minus 2x would be greater than or equal to 7. Okay, so this is the main line right here. If you can get this line here, writing your absolute value inequality without the absolute value bars, if you can get this step here, then you understand what's going on. If you have a hard time getting to this step, please contact me so we can talk about it some more. Okay, let's solve the two inequalities. So we'll subtract 3 from both sides. Negative 2x is less than or equal to negative 10. Divide everything by negative 2. So remember, if you divide an inequality by a negative, we have to switch the inequality symbol. So we'll have x is greater than or equal to 5. Or, okay, so real quick, I'll solve the second one. So again, subtract 3 from both sides. This time we'll have negative 2x is greater than or equal to 4. Divide everything by negative 2. X is, again, we have to switch the symbol. So x is less than or equal to negative 2. Writing our answer in interval notation. I'm going to start with the second guy. X is less than or equal to negative 2. This is the inequality, negative infinity to negative 2 with a bracket on the 2 union. And then if x is greater than or equal to 5, that's the inequality 5 to infinity. Okay, and then set builder, all real numbers x such that x is less than or equal to negative 2, or x is greater than or equal to 5. Okay, so again, our number line in the beginning. So one thing is that this number line here isn't to help you get the final answer. It's just to help you get this step here where you're writing the absolute value inequality without absolute value bars anymore. Okay, that's the point of this number line up here. But it does kind of help us with the final answer because it shows that our answer is most likely going to be in 2 sections. Okay, which it is, right? It's this interval here on the left, union this one on the right. Okay, and again, whichever you prefer, interval notation or set builder notation. Part E. All right, let's say we have the absolute value of 2x plus 15 is greater than negative 2. So the absolute value of a number is greater than negative 2. When does this happen? Okay, well, it's always true, right? This always happens. Okay, so it doesn't matter what number I plug in here for x, multiply it by 2, add 15, take its absolute value, I will always get a number that's bigger than negative 2. So the answer to part B is all real numbers. Okay, so again, let me write that in here for E, all real numbers. Part F, we have the absolute value of 7x minus 22 is less than a negative. When is the absolute value of a number going to be less than a negative? Okay, so the answer is never, right? The absolute value of a number can never be less than a negative. So here the answer is no solution. Okay, those are kind of the two special cases where if this comes up on a quiz or in my math lab, it's just to see if you're paying attention, so don't jump right in and draw the number line and draw your dancing people. Okay, first look at it and see if the question is, is it one of these two special cases? All real numbers, no solution, because if so, it's an easy problem and you can just answer it and move on to the next one. Okay, here are the two for you to complete and turn in through Canvas. So these are ones where you're writing it for me, so I want to see that number line in the beginning, and I'm looking at your work in addition to the final answer. Okay, I forgot to state it here, but your answer, either interval notation or set builder notation, one of those two, you don't need to do both. Okay, good luck. Let me know if you have any questions.